I'm super excited that everyone's here to learn about LangChain. This is my intention is we'll be kind of doing this as an ongoing series. What we'll talk about today. All right. I might be getting alerts along the way, so we'll see how that goes. What we're going to be talking a little bit about today is sort of an overview of what LangChain is, and then my intention is to sort of dive into some of the specifics in future meetings. But this should give you a really good sort of feel for how LangChain works and what it is and all that type of stuff. So it's very cool, and we'll sort of start off with a little bit about me if you haven't met me. My name is Justin Grammens. I have a company called Recursive Awesome and another one called Lab 651. We do AI consulting and training and software development. I also have started a company called Captivation where we actually use computer vision to take a look at presenters and use artificial intelligence to kind of help them become better presenters. If you're here, likely you're related to applied AI. So we have a weekly newsletter that we do, which I publish every week, every Wednesday. There's a podcast on artificial intelligence, which hopefully some of you in the audience here either have been on or are interested in being on. So if you ever want to be on the podcast and talk about artificial intelligence, please reach out to me. I teach at the University of St. Thomas, courses on AI and machine learning. And then as I sort of touched on a little bit, Applied AI is a 501c3 nonprofit, and we do meetups, conferences, videos, podcasts, all that type of stuff. So this is being recorded. This will be put on our YouTube channel, which is at video.appliedai.mn. And then quick plug, we are having our next big conference coming up. It's on May 10th. So that'll be May 10th, 2024. Check that out at appliedaiconf.com. So quick agenda on what we're going to do today. We'll talk a little bit about what is a large language model and kind of what they're good at and maybe some things that they're not so good at. As I've been experimenting and playing around with and then sort of coaching and helping companies take a look at how they can apply this, there are actually use cases where they're not good. And so LangChain sort of helps in some ways sort of bridge the gap. Some of the faults of large language models, or some of the shortcomings, I guess is what I should say. We'll talk a little bit about LangChain, sort of how does it work. There are a whole bunch of components to it. And so part of my presentation today is, I'll show you some code here in these slides, but then I actually have a fair amount of interactive Python scripts, Python notebooks that we can go ahead and run and try different things out. If you aren't aware as well, all of the source code and everything like that is in the description of this meetup. So in the description of this meetup, there was a little bit of information about what we're going to talk about, but then there literally is a link out to a GitHub repository that's called Let's Learn LangChain. I encourage you to go out there. All of the stuff is there. These slides are there. All the Python notebooks we're going to go through are there. So everything's there for you to play around with. And at the end of this deck, there is also a QR code that you can use to scan. But if you're here because of the meetup, likely you have seen the description of this event, and you can just go ahead and pull all the code that's there. My intention to, kind of back to what I was saying earlier, is that I intend for us to continue to build on this. I continue for us to be able to add more and more code along the way, right? And as we get more deeper and deeper into certain aspects of it, this repository will grow. So that's the whole plan. And then the last thing that we'll try and touch on today is a open source project called Streamlit. I highly recommend you take a look at that. If we don't get to that today, I've done this presentation before, but if we don't get to that today, that will be the first thing that we'll talk about when we do our next Let's Learn LangChain follow-up. But it's a really cool way for people to take Python scripts and basically put a web UI on top of them, on top of that, and allow you to be able to host these scripts without actually having to know any HTML or any front-end development or anything. It's super powerful. And so where that will come in here is we'll be able to take a lot of the cool things that we're doing with LangChain, everything from retrieval augmented generation, which you'll learn a little bit about, to actually querying language models and stitching them together and using agents, all of that type of stuff. Now, like literally using Streamlit, you can take that Python notebook and put it into a very simple to use web interface that you can publish anywhere you want, or host it internally. And again, like I say, if you're not a front-end developer, this makes it super easy for you to do that. So we'll see if we get to that or not. If we don't, because I would definitely want to have enough time here for us to have questions and stuff, we will do that. in a follow-up one. So large language models, what are they good at? And actually, I'm going to try and hide this if I can, so I can actually read this. So what are they and what are they good at? So it's a type of artificial neural network, if you're not aware, that uses deep learning techniques to process, understand, and what I think is really, really fascinating is this whole idea of generation, right? I think that's really what has changed here over the past number of years with OpenAI and ChatGPT. And all of these tools you're seeing exploding onto the market, right? From not only text generation to video generation to image generation, just that whole generative aspect of it. So very, very powerful for us to use content generation, right? Create articles, reports, stories, even these areas where we always sort of thought, well, not really sure if it's going to be creative enough. Well, it is. Once you have enough information and you are able to build a large enough neural network, can actually do some really, really interesting stuff around being very creative. So content generation, good area for you to focus on. And I will say as well, just a side note here as I'm thinking about that, that can also mean code, right? So when we say generating text, think about that. That text could be English, French, Spanish, but it could also be Java, C#, what have you, right? So really, really interesting ways for us to generate content and have these large language models generate content. Language translation, this was one of the first areas actually that large language models were sort of deployed. And actually natural language processing was kind of done and used. This whole technique was used by Google years ago to allow us to do translations between numerous languages. And the power of that numerous languages stuff is kind of what I just said, right? In an English sentence, you can say, write me Python code to do X, Y, or Z. And it's translating that human English text into computer code, right? So really, really good at that stuff. Learning and research, I think, is phenomenal area for it. Summarizing information, right? So looking at a product requirements document, for example, and summarizing all of that stuff into something that you can just ask about, or just any sort of healthcare document, right? These highly technical documents, you could put an interface on top of it and allow you to start asking questions. So huge time saving there, right? You're not actually having to go through and look at a particular document line by line. You can just converse with that, right? So very, very good. And the last bullet point kind of brings it all home. It creates a conversation, a human-like dialogue, makes this really, really useful for humans, for somebody who is not technical to be able to just have a conversation back and forth with this chatbot. Or agent, and in the world of large language models, in the world of LangChain, they kind of call these agents. So let's move forward here. What are large language models not so good at? Here's an example of using ChatGPT 3.5. Ask it a current question, win the World Series, don't have access to that information, right? And obviously, you'll see that with ChatGPT 4, it actually goes out and makes the queries, but at the end of the day, these large language models are static, right? They're sort of fixed knowledge base, and we have put real-time queries and stuff on top of it, and that's really what I'm going to talk about today is how LangChain solves a lot of these problems for us. But out of the box, large language models are static, right? They're limited to what was available when it was trained on. Context, right? Common sense reasoning. So they kind of can struggle with domain-specific context, and they can be very prone to hallucinations. Depending on how you prompt these and depending on how you ask the large language model, it will generally give you an answer all the time. Oftentimes, it will end up giving you what sounds like a very, very good answer based on all of the information that it knows at the time, but it lacks context, right? And so this is where it's different than Google. This is where I talk to people about, Google is it's more of a research thing. It's going to give you a bunch of stuff and let you figure it out. These large language models are really kind of giving you the answer, and oftentimes that answer can be incorrect based on the data. Bias, right? So there's a lot of biases and inadvertent data that's been captured by these models. And it can lack human emotion as well. I noticed that people are putting stuff in the chat here. I'm going to try and not have that mess with my presentation here, but certainly along the way, if there's things you want to add or ask questions, I'm kind of running this thing solo here, so we'll see what happens. But my intention is to have plenty of time for us to go through those questions here at the end too, so we can ask those. But if you have ideas, go ahead, drop them in there, and we'll try and cover those along the way. Continuity is one area where it's been lacking. Now, it's getting better with, basically larger prompts that we can add to the context as you ask the follow-up question. But generally, out of the box, it doesn't maintain any continuity over long conversations, and it can lose track of previous conversations because that context window just can't actually hold all of the information. And there's some really interesting stuff going on where, with regards to, they're loading in a lot of data into vector databases and then reconstituting that. But like I say, out of the box, a lot of LLMs can suffer with that, not actually understanding the overall context. And then, as I touched on a little bit, it really depends on the user input, right? So the quality and the clarity of your questions and how you ask it can really dictate how well you'll do with regards to the power of what the LLM can give you. So those are a little bit things about sort of what large language models are, and sort of how they've been good at and things that they're not so good at, right? So how does LangChain try and address this, right? And what is it? So it's an open source framework. It's been developing applications powered by large language models, and it's actually been around since October 2022. They really have sort of become, in a lot of ways, if I'll say it here, I'll probably say it a couple times, the orchestrator, right? LangChain can kind of sit in the middle of these contexts and these questions, these prompts that come in, and based on all of the way that the questions are asked, it can start doing some very interesting stuff, right? So it enables applications to be context aware, right? You can actually have it take a look for current events, right? You can have it load in documents from your own private repository if you want. You can actually have it learn about current vocabulary, right? And so again, the power of this is that you can host this yourself. You can run this, right? People say, oh, ChatGPT has all this stuff built in. Yes, it does. But what if you are trying to build your own system within your own environment and you want to use an open source tool? LangChain is probably the best choice for that. And you want to make your application be context aware. This is a great tool for you to use. It can also reason. It can start creating these custom functions, and you'll see these agents that are available. There's literally hundreds of different tools and agents out there that you can now have access to, because many companies have built their own agents to work within the LangChain environment. So I'll show you some examples of that. It makes it really easy for you to add memory and history on top of your large language model, right? So if anybody started using OpenAI since the very beginning of their API, which I was one of those people, it was one of those things where you really had to, manually through the API continually to send in the context, right? And it's one of these things that is, it can be annoying as a developer to actually have to build something as simple as that. And so this is where LangChain really shines. It basically provides this abstraction layer on top of what you're doing to provide you with memory and history. And it also creates a really rich set of prompt templates. And we'll talk about templates building your own. But what's really cool is when you ask a particular large language model or an agent to do something, it prompts it for you, right? And so it creates this nice, long, elaborate prompt that you don't see, actually, but it then allows your application to function as best as it possibly can, because it is actually prompting the agent in the right way that it should be. So some examples of where it's being used today. Chatbots, obviously, is just a great area. This idea of retrieval augmented generation, right? So if somebody actually has a large language model that needs current data sort of helped out along the way, and needing to be able to retrieve current information and augment the response that the large language model has, that is a prime example of it. And then this idea of summarization, right? So take an entire document. We'll show, if you have a chance to take a look at the source code and stuff, I'll show an example where we sort of take the Constitution and we can start asking it questions, using summarization. But that's just a very simple example of just pulling in maybe one or two documents. This entire system can scale, right? And the beauty of it too, the last bullet point that I do want to highly emphasize here is that it's model agnostic. So you can actually start using one model and then with very little code, be able to flip over and start using a different one. And I'll show some source code around that. It's gaining in popularity. I mean, like literally just, I think it was probably earlier this month, LangChain, they landed a $25 million round. And so it was started as an open source project. It still is an open source project, but they're actually now providing a number of sort of enterprise features and other additional things that you can get if you want to be an enterprise customer. But just the sheer interest has been just amazing over the past couple of years. They are actually hiring as well, just an FYI I've seen. And, this seems like a really, really cool project. But, 5 million monthly, downloads. There's tons of apps, lots of contributors. It's a super rich environment. And I would say it's probably the best environment to get into if you want to start dealing with large language models and being able to write applications on top of it. And I guess that is one of the things that I would like to say too, is that, as a software engineer or a developer, you're kind of like, well, how do I deal with this large language model? How do I need to write all this code to go on top of it? And that's really at the crux of it is what I think, LangChain does. It provides you a tool as an engineer to be able to interface with these things. So it's an example of retrieval augmented generation. This is what ChatGPT is doing, right? If you actually ask it, who won the World Series in 2023, it says, I'll did a quick search, and here's some more information on what I discovered. Now, whether or not they're using LangChain under the covers, maybe, who knows? But this is a prime example of where LangChain can really be powerful. A quick overview here of sort of the entire application stack. Everything from observability, which is actually very much needed, I think, is what I would say. I would say over the past couple of years, as I've been using LangChain sort of out of the gate, they've been planning on doing more observability and more tools to allow you to understand exactly what's going on. And so they just recently released this thing called LangSmith. And that's one of those tools, that is available for anybody to use. But they also, of course, have enhanced features if you actually go to their paid model. But what happens with a lot of these things is like, how do you monitor the application? How do you evaluate what the responses are? How can you actually have human in the loop and start doing annotation based on what's there, right? So this whole idea of observability, it can be, a lot of frameworks don't offer that, right? And so this is one area where I think LangChain itself, but also the creators of it really thought that LangSmith and this idea of observability is a very important piece of it. They have a component called LangServe, which will basically take your chains, and then you spin up this little thing called LangServe, and voila, you all of a sudden have a bunch of REST endpoints that you can call. You can obviously host it and run it your own way. LangServe is just sort of a one easy command line thing that you can run to have access and spin up your own stuff as a very, very simple API. They have templates, just a number of different reference applications and implementations that are there. And then you kind of get to the core of what it is. And you can develop LangChain using Python or JavaScript. The code that I have there is all in Python, but it's really one-to-one. All the features are supported on both of them. You can create chains and agents and agent executors, and that's what we'll talk about today. Is really we'll get into mainly the stuff that's here in the dark blue box. So you can create your models, you can have prompts, and you can start loading in documents, as I talk about here about document loaders. If you don't know about vector stores or embeddings, LangChain handles a lot of that information for you as well. I'll show you an example of that, but that allows you to take a document in and then essentially create what are called embeddings and store them, and then allow you to make questions against it. And then the very lower stuff here on the protocol is something we won't really talk about today, but I actually think it's something that I will go into in a future one. But they basically have an expression language. It's called the LangChain expression language. And most of these examples that you'll see that I did are pretty straightforward. It's just kind of sequential code that's calling things. But if you want to work that into production, believe me, you're going to want to have async operations. You're going to want to be able to batch things up. You're going to want to have fallbacks. Sometimes these large language models don't return things that you're expecting. You're expecting an int to come back as a result, and it comes back a different way, right? So you can actually trigger different code using the expression language very easily to say, okay, if it didn't work this way, try that way, right? So this whole idea of fallbacks and parallelization, all that sort of stuff is a component of the entire framework. And you can add that in like very easily, but I won't go into that at least this time, but it's a really powerful concept that they've added in as well. So I've talked a lot about LangChain just using words, words and sort of explaining it at a high level, but sometimes a picture is worth 1,000 words. So here's the major components of it. Beginning of the day, you have a user. They're going to interface with it, with any model, really by a prompt, right? And so prompts get created, and then they are essentially, asked and sent into the model, right? And so I'm going to show you here just with regards to pictorially how it's working, and then we'll actually use code to do some of these steps. But want to give you an overall idea of what the entire sort of life cycle is with this. So those models can be, anything from OpenAI, Llama, DALL-E. They have a whole bunch of ones. Gemini is now supported as well. You can choose any sort of model that you want. And from number 2 to number 3, then, is that you can start chaining these prompts together. And I'll show an example where you can say, based on the output of this model, then go ahead and call this prompt, create the output, and kind of chain together a number of different prompts where you can just ask one thing, and internally it can go ahead and chain a number of the different prompts together and ask the same model, a different model. And again, it allows you to do all that stuff sort of programmatically under the hood. You'll see that memory is listed here, right? So, we've got the capability of being able to sort of have memory within these models that can get then injected at the time that they are accessed and evaluated. And then this is where things get really interesting, I think, is that you start looking out at different agents. So these agents then can be sent off to do things. And I talked a little bit in the last slide about parallelization, right? How do you make things parallel or run things in parallel? You can run these agents in parallel and have them do a number of different things. And one of the most powerful things that they can do is to call a series of tools. So these tools can do everything from search the internet. They can do calculations, examples. They can look up stuff on Wikipedia. They could query your database if you wanted, right? They could search your own private repository. They could call your APIs. They could do all that sort of stuff. So these tools can then be accessed by these agents to do a number of different tasks. And then based on those results, the information then gets sent back into a model, because at the end of the day, you typically, you don't have to, but typically actually want a human readable output. You want something that is natural language to the end user. So this is where it's really cool, where your agents then can actually interface with the model and then give a result back to the user, right? So that's sort of the overall life cycle of what happens within a particular within LangChain, and sort of how users interface with prompts and models, and how LangChain can sort of, as I said, orchestrate a lot of these different components together. So let's start with the models. So I've just got some code here just as some examples, and what I'm showing here is basically you can create, and here I'm creating 3 different LLM variables, right? Using either something from Chat OpenAI, we've got an Anthropic option, and we have a Google generative AI. And I talked about being model agnostic. Yeah, you typically wouldn't create a variable with all 3 of these. You'd probably choose one or the other. But the cool thing about this is if you decide one day, well, I want to start using Anthropic instead in my code, all you got to do is swap this out, right? The underlying plumbing and everything has been figured out, and you can start using other models sort of right away. So you're not locked in. That's the thing that I think is really powerful with this, is that you're not locked into a specific model or a specific architecture. And if one day you're like, I want to use my own local model, right? I didn't even show that on here, but you can literally give it a path to a model that you have hosted on your own laptop, for example. That works just as fine sort of out of the gate. So, there's a lot of really, really power here with allowing us to be able to do this in code and swap them out as needed. So that's the models piece. Let's talk a little bit about prompts and sort of prompt templates. I'm assuming a lot of people have heard about the various shots around learning, right? So zero-shot learning basically enables a model to make predictions about data it's never seen during training. So this is how you would create a prompt. And again, I'm just going to use the example code here is on Chat OpenAI, but you can use anything that you want to, if you're not familiar about temperature also, temperature 0 is really sort of forcing the large language model to, in some ways, not be creative, right? Based on what the next the probability of the next word is, just go ahead and take sort of the tried and true path. Whereas temperature 1 is sort of middle of the road, and temperature 2 is very creative, right? It can actually start pulling in different words and kind of go down this sort of random walk, right, as it gives the responses. But what I want to show here is, yeah, you can fiddle with these temperatures, and you can also choose the maximum tokens that you want to have respond with. And so tokens are the way OpenAI charges you based on usage. It's typically around 8 characters or so, so maybe a word and a half or so. And you can limit it to say, okay, this is the maximum length I want to have you return to me, right? And you can crank that down or crank it up, whatever it is. But if you want to keep it succinct, you can make it smaller. And then you have your variable, basically prompt, generate for me a haiku about a dog, and then you just call LLM invoke, right? And so this is a particular case, talking about zero shot. It hasn't actually seen an example of this before. I'm giving it the first time, say, generate for me a haiku about a dog, and it went ahead and with no shots or no prompting ahead of time or no examples, it went ahead and said, loyal pup so sweet, tail wagging, love complete, boundless joy we meet. So really just a very simple example of how you call and use an existing prompt. This idea of few shot learning, which is really around sort of giving it some examples based on a prompt within your prompt. And then based on that, it knows how it should respond. So here's an example of, I sort of set up the LLM variable the same way. I have a prompt, but you'll notice I say tennis, racket, baseball, bat, golf, and then blank, right? So you invoke this prompt on that, and it is smart enough to take a look and say, oh, I've seen 2 other examples of this. They want club back on that. But so here's an example where, we basically have done a few shot prompts. I touched a little bit on this idea of templates. This is how you do it in code, right? So you create the prompt template object here. I just assign it to a prompt variable. I tell it what the input variable is, and then I say describe a perfect day in blank city. And you basically use this annotation inside. And when you run it, based on the input variable, it will go ahead and plop it in there. So this is a very simple example where we have just said, okay, whatever you pass in, I'll go ahead and substitute it here. You'll see some areas in the code as we get in there. The power of this is that these people that have created these agents and these tools have created an entire template for you, and you don't actually have to deal with that. You just basically tell it what you want to have it do, and it has created a paragraph or more, a lot of information to tell the large language model, here's what you need to do, and it substitutes it in for you. So this is an example, though, with regards to creating a simple template that can be reused. And the idea of this is just, allowing people to reuse templates over and over again. So that was a very short thing about prompts. We'll talk a little bit about chaining. I touched on this a little bit with regards to being able to sort of chain things together. This is an example of actually passing in 2 variables, right? So we create a template that is called our title template. We basically want to create a blog or the title of a blog post on a topic and a language together. So we can say, okay, as we invoke that chain and run it, we can give it a topic, the best way to learn a language, and the language is French. So in one prompt here, you can pass in multiple essentially commands, right? Essentially words of what you want the template to do. And then you can build these things called sequential chains. And so I talked about that a little bit before, where you could have the output of one, then give the response to the other. So this is an example of, we create one template that says create the title for a blog post on topic. And then we have another one that says create a blog post on the topic of title. And so we create our 2 large language model chains, and we create a variable, or we instantiate simple sequential chain, and we add in our 2 chains that are here. And then we can say, okay, my main question is how to run a marathon. And it goes ahead and calls our first template, which is create the title. And it created this title called Mastering the Marathon, Comprehensive Guide of Training and Finishing Strong. And then it went ahead and said, create the blog post of the topic of title. And it went ahead and created, I don't have enough, basically room here to show you, but it then took, based on the output of it, went ahead and built the response for that. And you could run this over and over again, right? You could have different, you could have it, I tell you, if you run it a second time, you'll get a different title, and then you'll end up getting a different blog post, right? And so these things are tied together in a kind of a cool and unique way where, again, programmatically, you can make these things sort of sing together and sort of orchestrate a number of different things. And imagine if you were to build a system that needed to maybe generate some source code, and based on the output of that source code, then go ahead and call Wikipedia, and based on that, go ahead and generate a prompt. There's a lot of different things that you can do to sort of tie these things together. So super, super powerful. I was talking a little bit about agents and chains here. Let's get into some examples, right? So if LangChain is like the conductor of the entire system, with regards to a prompt that comes in and conducting it, I would think of the agents as the conductors of the particular tools that can be used, that are at the disposal for them, right? So agents can leverage large language models for the next action. So you can actually ask an agent, what is the current age of the president divided by 2? And here's an example of what it does. And you can turn on the verbose output, and it will go ahead and tell you kind of what the large language model is doing. So based on this question, it asks the large language model, what should I do next? And the large language model says, I should use a search engine to find the current age of the United States president. And then it calls search, and then it actually does a search to find out what the answer should be. And then it does what they basically call thought observation, where it takes that value and says, I don't know how to actually divide, but I should use a calculator to divide this, right? And so it can actually call a calculator action to go ahead and make that division happen. And then it says, based on the thought, the large language model says, aha, okay, now I know the final answer. The final answer of the president's age is blah, right? So this is what you can run out of LangChain. And this is literally sort of under the covers what's happening when you ask ChatGPT to do something that maybe doesn't have current information for on right now. But this is sort of how LangChain stitches that all together using their agents and their tools. I talked about what tools are available and what agents are available, whatnot. There's a tool for everything. I mean, pretty much most SaaS-based platforms now are sort of allowing tools, they're building tools, very, very simple tools, to allow you to access their information, right? So you can use anything from, I see Twilio over here, right? So, how could you actually have SMS messages go out? Twilio provides that, right? How could you actually get information off of YouTube? They provide a super easy way for you to be able to pull transcripts off of YouTube's. File system is another example. If you take a look through the source code that I have out there, you can start asking questions about your local hard drive. Hey, how many files are in a current directory? Right? It will actually execute that, right? So there's literally hundreds of tools out there that you can now have access to, which is super powerful, right? As you build these systems, you're going to be pulling in information and data from not only local sources, or your own internal sources, but also, outside external sources and also external services as well. So really, really powerful. So let's see some examples. See what I have here. I'm going to kick out of this, see if this works. Well, everyone can see my screen. I'm going to try and make this go like this. I'm going to assume, since I didn't hear anything from anybody, everyone can sort of see the screen. So,
Yes.
perfect. Thank you so much for letting me know. Everyone's sort of minimized. I can't see. So we'll spend the next time here sort of going through some examples and running these Python notebooks. And again, all of this stuff is out on the GitHub, and you can run these. So what is a Python notebook? I guess if you're not familiar, it's basically a Python file that you can run then little segments of code, right? And so you can use the Python installer package pip to install these packages, to install OpenAI, install LangChain. I guess that's one of the things that I'll mention is we'll be interfacing with OpenAI, but you could obviously interface with anything else that you want to as we sort of move along here. So you can install this, and then I want to talk a little bit about some other chains, right? So those of us that maybe deal with databases, for example, this might be useful to you, but I'll go through a couple different chain examples and sort of show you sort of what's going on here. So we have a simple database here that has a series of tables, and this is actually a free database. It's just open source database. It's called the Chinook database. It's listed over here. I actually put something here in the chat. Yes, Python notebook equals Jupyter notebook. They are both one in the same. We have a database here that has a whole bunch of different tables, and this is a free. Again, like I say, it's an open source database. It's just loaded up with kind of a music store, right? So it has albums and it has artists and tracks and invoices and customers and all that sort of stuff. So this is a diagram that somebody else built. AI didn't build this. But what we're going to do is some pretty cool stuff. Is basically being able to infer just what it can do with SQL queries. How can it actually understand what's going on, right, within the database? So here's an example where we just import a couple objects here. We create a database variable, and then we use our SQL database chain. And this is where I was talking. There's a number of different database chains and agents that you can use. But based on this, we create our own DB chain variable. And then we can start asking questions, right? So I can say DB chain run, and we'll start asking questions in English. So I'll go ahead and run this, and I'll say how many employees are there. And look, under the covers, it basically does a select count star from employee. And based on this, it got this result. And then to be clear what it did, it then asked the large language model, return this in English, right? So the answer isn't just this 8 inside an array. The answer was there are 8 employees. So what's really powerful about this is what I want to be clear is this is allowing you to interface with a bunch of data stored in a local database just using English. Right? You're just asking it questions using the English language. And from somebody who is, somebody as a DBA, you're like, oh yeah, okay, whatever, you can do this. No, this is actually pretty powerful because it opens up the capabilities of anyone on your team to start asking questions about the data. And so here's an example where I say list the total sales per country and list the top 5. Now, notice the other thing that I want to say is there is no sales table here. There is no sales table, right? But what it's smart enough to know is basically say, invoices are roughly the same thing as equal to sales, right? So it went ahead and did this select, got the SQL results here, and then batch, kind of brought this all up together and gave the answer, the 5 countries with the highest total sales in the USA, or, yada, yada, yada. So it's not just dumb being like, well, okay, I'm going to look at the employees table and basically sort of, star equals, or, select star from that table. It's actually making intelligent decisions based on the English language and what it has seen in there, right? You can ask questions, what's the country's, what country's customers spent the most, right? And so in that particular case, it can go ahead and sum up, right, the actual answer. And it says the country with the most sales is USA with the total of blah, right? So it didn't just dump back a number. It didn't just dump back this. It summed it up, as well. And so you can sit here and play around kind of all day with this stuff, right? And again, I just chose an open source database because we need to just get some data and play around with it. Play around with it with your database, right? There's what's going on here is it's using the large language model to help us basically understand and write out the context. But at the end of the day, your data is what's actually being queried. And this is kind of cool too. So I say describe the playlist track table. Well, the playlist track table is actually a virtual table. There is actually an ID that is sort of tied in together with regards to the playlist ID and the track ID. And so what this thing does is it says the playlist track table contains a relationship between playlists and tracks. It knows that each row represents a track that is included in a specific playlist, and it has 2 columns, yada, 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 right? So this is nowhere to be found really in this diagram or that somebody had drawn. But again, as you're exploring, as you're playing around with it, maybe you throw in a database you have never seen before, you have no idea what the ERD is for that, you can start asking questions about it, right? So really cool. This type of stuff is really allowing, I would say in some ways it's allowing people that maybe don't know SQL to be able to access it, but even if you know SQL and you could write all this stuff, this is a way more user-friendly interface and a way more easier way for you to actually start asking questions about your SQL data, right? And people talk about GPTs and being able to load their data into a large language model and ask questions of it. That's all great, very, very cool, very, very useful. But here's a particular case where you might have a whole bunch of data in a SQL database, and you could easily access it just using a simple DB chain for that. I want to talk a little bit about this idea of program-aided language models, right? So where large language models have failed, really, is being able to do math and really providing deterministic, repeatable responses, right? You might see, even though you crank the temperature down to 0 on a particular prompt and you ask the model over and over again, believe me, I've seen this, it will respond very, very well on a lot of things, but sometimes it actually will get tripped up. And especially, it can get tripped up in areas around math. So this idea of program-aided language models basically allows us to use a smart chain that will actually write code and then execute that code to solve the problem. And it's sort of a new technique, newer-ish technique. It's been going on for many, many months. There's a number of papers that are out there over the past year where they've been experimenting around with it. And again, I'm just basically creating variables here. I create my large language model using OpenAI. One thing I do want to say here is I'm using OpenAI, but I'm not actually specifying any of my keys for it. I have an environment variable that's set under the covers because I obviously don't want to show you my keys. So you can set just an environment variable under the covers, and then you can access all of this. You can actually pass in your specific key on how to access OpenAI. But you'll see in a lot of these examples, of course have just left out my keys because I don't want anybody to be able to see them. But that's kind of what's happening under the covers. LangChain sort of says, hey, if you create this variable called this, then I can access it while we run it. So I create this pal chain from math prompt. There's a lot of different prompts you can use on this, but let's go ahead and I have two different questions. It's a typical math question, right? Jan has 3 times number of pets as Marcia, and Marcia has 2 more pets than Cindy. This type of stuff, would typically throw off a large language model. So I'm going to create 2 different variables here, and let's just ask it the question number 1. You kind of see I've got the output below. I'll rerun the output sort of here in real time. But what it does is it actually creates a code. It actually creates a little function called solution, and it has all this information. And based on this, it starts creating variables. Creates Cindy's pets. And based on the question that you had here, Marcia's pets is two more than Cindy's, and it goes ahead and runs through all of this. And not only does it write the code, obviously, it then goes ahead and runs what's there. So you can do that with that question. I will have a different one with regards to the cafeteria and apples, for example. Same type of thing, right? These are things where it realizes that that they used so many for lunch and had to buy 6 more, so it subtracts them and then adds them back in again. Really, really powerful. So that's called program aided language models, and so it allows us to, again, based on things that it maybe doesn't know about, could it actually write the code? And I've seen other things being done. If you start asking, I even saw this the other day with ChatGPT. I asked it what the current time was, and it was really interesting. It actually wrote the Python code to generate what the current time was, right? But then if you ask it again later, it oftentimes remembers and then ends up writing the right thing. But you're seeing this more and more. A lot more of these systems here are starting to sort of build programmatic output to then execute, which again can be deterministic. Like if I run this over and over and over again, this is exactly what it's going to do because it generates code and the code ends up getting executed the exact same way. So very powerful technique if there's certain operations you want to have be generated over and over again. The other thing that I think is pretty cool, and again, these are just one of the many chain options that are out there, is actually being able to call APIs. And so in this particular example, we're going to use this service called OpenMedio, and they have a chain. Actually, they don't actually have a chain. We have a chain called our API chain, and we can pass in 2 different things. We can pass in the large language model, and then we can actually pass in a link to their docs. So this system is going to take a look at the OpenMedio docs, and based on what's there, it will say, okay, if you're asking for a specific thing, here's the query that I need to build. Here's the HTTP query I need to build, and I'm going to go ahead and execute that query, right? So this is just a link, off to, if you'll see there, the API documentation that's there, and if I actually, I'm going to go ahead and just run this one to make sure the variables are there. And if we go and ask the question, what is the temperature like right now in Minneapolis in degrees Fahrenheit? Again, I didn't tell it how to make this query, right? This is the power of this stuff is you can actually have systems be smart enough to take a look at docs and generate their own API calls. So you don't even have to write this anymore, right? So what does that mean, right? What does that mean to highly intelligent systems if they're actually generating code and executing stuff on the fly based on documents? So it entered this chain, it created this actual query string, and it executed that query string, and it got back a bunch of JSON here. And then what did it do? It actually took that JSON and ran it back to the large language model. It didn't just dump out the JSON back to us, right? It said the current temperature in Minneapolis is 51.5 degrees Fahrenheit, right? So based on this information, based on what was asked, it then was actually able to respond to us in a very natural language way, which is what we want to do. So really interesting stuff that you can do with API chains. We have a couple other ones that we'll get to here as well, probably not today. We'll start talking about agents, which really sort of blows the doors off this type stuff. But really awesome examples, probably more for people that are writing code or are interested in getting deterministic responses or want to interface with just general APIs here. Super powerful for you to be able to do this. I want to talk a little bit about functions and your own functions, and then I think I'll probably end up opening it up to questions here, and because I see a bunch of stuff going on in the chat. And then I think we'll do a follow-up here where we'll dig into the chains. We can do a whole bunch of stuff around documents and PDF loaders, and we'll do all the stuff with sort of Streamlit that I was talking about. But this allows you to create your own functions. So let's say, for example, you want to, and the example that I'll have here is basically having a little bit of code that basically allows us to find the current time based on a given location, right? And so, we obviously could call an outside source, but in this particular case, what I think is really interesting is, let's say you have your own function to calculate something, or your own function to look up something within your local repository, or really anything. What this allows us to do is tell a large language model, say, if you get a question that's similar to this, use this function, right? And so we can build up a whole repository of certain actions that we want to have done specific to us, and they kind of are finely tuned to what this large language model can do. And the large language model, obviously, if you ask it just general stuff, it'll give you general stuff. But if you ask it specific things and it wouldn't know how to do that, like, for example, get the current time at a given location, the large language model can say, aha, okay, this is what I need to do. So I'm just creating a very simple Python function here that just says get current time, and it just uses the datetime object here. This is where you can define a list of functions. So I'm only defining one. As you can see, this is actually an array of functions. You can put a bunch of different stuff in there, as many as you want. But the description is what matters, right? So what you're telling the large language model is, here's a series of functions that you can call as needed. If it's related to the current time given a location, and you'll see I don't actually ask like a specific type thing, but the large language model is smart enough to kind of look and see what's coming in and what I should call. Then we define the function that we should be calling, and then the parameters that should be getting called. So this is our function, get current time. The parameters are going to be passed in, which is going to be the location, and then this is the code that would actually execute. So I'll go ahead and do that. You can set up your messages. So this is the content that we're going to be passing in. So I'll say, what's the time in Minneapolis, for example. These are just, I'm creating our objects as well, and then handling the response. So I'll go ahead and make this call here, and we can basically ask, and based on this question that I asked, what's the current time in Minneapolis, it went ahead and called our function, and we can respond with the current time. So that's calling, that's calling our function. Now, if we were to go back and say, okay, I don't want to ask what the current time is in Minneapolis. I actually want to ask what's the size of the moon, right? And so this would be disastrous if it tried to call, our function, and it didn't, right? It was smart enough to say, look, I have a list of these functions. There are all these things that I should possibly do, but you didn't ask anything related to the current time. I'm just going to skip over that. I'm just going to go ahead and basically use the large language model sort of as is out of the box and ask it the question, and it went ahead and did this. So this allows you to create, again, like I say, your own sort of pathways or your own sort of responses. that maybe aren't actually covered by a specific chain or aren't covered by a specific agent or all that type of stuff really allows you to execute your own functions sort of like in real time, which is really, really powerful. So let me hop over here to the chat. Let me see if there's any sort of questions. And I guess, you know, I'll sort of thumb through these and see if there's any other questions that people have in here in particular. But if anyone wants to sort of unmute themselves, I'm curious to get any sort of feedback for what people are asking about, what they're thinking. Srinivas.
Yes, Jason, thank you very much. I mean, this was an excellent presentation. Thank you for putting this together. I just have one question on that SQL chain. Um, were the column names sent to the large language models to understand the semantic meaning of those columns?
My answer is yes. I'm not, I don't know if I haven't delved in to basically prove that, but as you start asking questions about it, it has to know beyond just the table name, what it needs to be looking for. So I would say one thing to do is, you know, instead of saying, give me all of the customers, for example, say, give me the customers with the name Jan, right? And so that I think that might prove what you're looking for, right? It would basically do a select for a specific column name. And yeah, we could definitely, you want to try that? Let me see.
Yep, I'll give that a try. Thank you, Justin.
Sure. I was even saying I could hop back into the code and try that right now if we wanted to see what happens. Somebody else has a question.
Hey, Justin, I have a quick question.
Yeah.
So this feels a lot like something that you had a speaker at one of your conferences a couple of years ago for Lucy AI, where it was an AI toolkit that basically and at runtime decided the right method to use to solve the problem or to address the prompt. Is that really what LangChain is doing? Is it's giving you a more intelligent way to approach solving these problems on the fly?
I don't know. I would say maybe that's a component of it. I think, you know, the guys at Lucy basically have provided an entire product that allows you to basically put all your data into their infrastructure and then allow you to ask questions about it. I would say that LangChain provides not only that, access to that, but then it provides queries out to external sources. It provides SQL queries. So you're right, there's a real-time element to that, but it also, frankly, allows you to be a software engineer and kind of the world is your oyster, right? So nothing against Lucy, but there's no code involved in any of that. It's basically, hey, you know, here's a conversational interface you can have on top of all of your documents that you have there. You're not in there writing code. So I would say LangChain, I mean, I'm kind of on a mission to let people know the power of this thing. And a lot of people are like, well, that's just a developer tool. Well, yes, it probably is. It feels a little codey, right? There, I'm showing you guys source code. But at the end of the day, what it allows us as software developers to do is actually do what we do best, right? Which is actually write code and stitch together a number of different things at sort of a base level. You can go super deep on this stuff. And based on the responses, you can figure out, okay, I should or shouldn't do this. And so again, Lucy, I would say, touches that with regards to accessing data, but by no means is it at all, I feel, at all related to this, because this allows you to really get into the nuts and bolts of your entire system.
Yeah, absolutely. Lucy, you sort of provide something to, and then you let the methods go free. Here, you're like, the world is literally, it's whatever you want it to be. So thank you very much. Appreciate it. I just want to make sure I was tracking.
Yeah.
Thank you so much. This is great stuff, as always, Justin.
Yeah, thanks, Arthur. Dilip.
Yeah, thanks, Justin, for the nice presentation. Quick question. So I've worked on LangChain a little bit, not too much on agents yet. You know, so a question that might help everybody is when it generates a thought, right? When it's deciding what to do, the LangChain and the agent really is deciding what to do, React agent or whatever, and it has all these tools at its disposal. Is it really making a call to LLM, giving it the description of the tool and deciding if I should use this tool or not? So there's an extra call to the LLM happening there internally. Am I right?
Yes, yes. In fact, boy, here, let me share my screen real quick. Maybe we can do this. I haven't gotten to this yet, but I will show you guys something. Let me go to the desktop because hopefully people can see my screen again. And this is the next one that we'll be talking about. And what you're talking about is agents. So basically, you can create these agents, and you can tell it a bunch of tools that you can use. And what's interesting is whoever built this agent, there's actually a search, what's called SERP API, but it's basically an agent that allows you to, or a tool that allows you to query Google. They have defined it with their own description, a search engine useful when you need to answer questions about current events. Input should be a search query. So that's loaded into the large language model. When you ask it a question that kind of in the large language model sense says, okay, this is actually something that I should use, it makes the decision at real time. Now, the other thing that's really cool is look at this below here. It says, this is the template now. So the agent then, and I was talking about earlier, like you don't have to write your templates. The agent now says, what do I have access to? And so it says, answer the following questions as best you can. You have access to the following tools. And the agent says, now I have access to a search engine. As you see up here, I also loaded this thing called LLM Math. So the agent now looks at all of the knowledge that it should have, and it says, oh, okay, but also I have access to a calculator, for example. And so this is what you need to answer questions about math. Now, me as a developer, I didn't actually have to write this prompt, right? I didn't have to go through all of this stuff here to sort of cue the large language model up, to tell it what it needs to do and what the inputs and outputs should be. The actual tool did that for me. So to kind of answer your question, yes, it's and they have written that search for you, and you don't need to worry about it. And then even when you go ahead and call into it, it has sort of told the LLM what it has the capabilities to do. So we'll go over this agents in like the next one, but I think I've answered your question. I think with that, it's it's sort of prompted the LLM for you, and then you can just use it right out of the box.
Thank you.
Yeah. I think I saw one more here. I wonder if I can actually stop share real quick. Brent. Or did his hand go down? We've got
Hi there. Hey,
oh, Brent, you there?
hear me coming through?
I can hear you barely.
Okay, is this any better?
Yep, that's better.
Okay, wonderful. Well, first of all, I want to say I'm very impressed by what I see with LangChain, and I'm certainly going to install some software when I get home. The question is about the money. Can you help me understand more clearly how licensing and payments work in the whole ecosystem? I think the way I think it works, I think LangChain is free, and some of the tools and infrastructure are free, and then there's like usage for APIs depending on which LLMs you want to access. Did I get that right?
Yeah. So everything that I'm running here is completely free. LangChain didn't charge me a penny for any of that stuff that's here. But where I am getting charged is all my calls to OpenAI. So they're hitting off me a little bit here and there. OpenAI actually just changed their policy recently. If you did or didn't know, before at the end of the month they would charge you for all your usage. Now they have moved to a token-based thing where you actually have to load it up with X number of dollars ahead of time, and then they sort of like work down against it. So that's where I'm getting charged, is basically the use of LLMs. Basically the API hits. Now, again, if I were to access another API and they wanted to charge me, certainly. But you could get around that, right? So there's a lot of examples out there, I would say. If you want to install Llama locally and just run it, you can do that with literally all the stuff, just a couple lines of code, and you can start accessing your free open source large language models. But out of the gate, you can get going right now with LangChain, $0.
That is wonderful. Related, another question related to software setup. Does LangChain fit into, say, models around image generation? And if this is a big topic, I'm just not going to worry about it. But I mean, can you like prompt it for images, and then
you could prompt it for anything you would prompt OpenAI for. So yes, yep, it will do all that stuff. In fact, that's a pretty interesting thought that I've had. Maybe one of our follow-ups we can show that. And this was all based on text. But yeah, again, it's orchestrating stuff. So it's riding on top of sort of what the large language models can support. And so if you're interfacing with DALL-E, for example, yeah, it would be able to get a response and generate that as well. That'd be a fun follow-up example. I'll start working on that.
Wonderful. Thanks again so much.
Sure. All right, Deepak, we've got only like a minute left, but because I want to be cognizant of people's times, but I appreciate everyone attending here today. So yeah, you got a question?
Just real quick, yeah, great presentation. Basically on the and thanks Brent for bringing up the cost thing, because that's something I think people should definitely keep track of their usage when they use that type of stuff with OpenAI. But specifically on the part where you talked about the SQL database, we have a database that has very domain specific names for things and in relations to each other. How do we tell the LLM what those things mean? Because on your particular example here with Chinook, I think the language model knows what a record is, what a customer is, and all that stuff. We have very specific names that we name the tables as. How do we tell the language model what that means so that it knows how to put things together and make proper SQL queries?
Yeah, that is a great question. And I will say I haven't done that specifically, but I can tell you sort of how you would do it. I think you would do it with basically pre-prompting it. So just like I showed you before with the template where I had X equals Y, Y equals Z, Z equals X, all that type of stuff, that's what you would do. You would tell the large language model ahead of time, this is actually means this actually means this means that. And I've done this before. It's called fine tuning. You can basically fine tune a large language model. And OpenAI allows you to do that out of the box. You can actually push to them a big JSON file. And I've used OpenAI to say, hey, take an English sentence and translate it into some sort of an API call that it would have no idea. Like this variable equals this, append it to that, all that type of stuff. So that would totally work here. You would literally create your own little template ahead of time and say, here's the domain specific information about this. And I would be surprised if it didn't work. I think it would work. It would basically be like, okay, I've got this knowledge about it, give it a try. But yeah, I think that's how you do it.
I'll give it a shot. Thank you very much.
Yeah, sure. Cool. All right, everyone. We're just 2 minutes late, but I had just a lot of fun doing this. I'm thrilled that people showed up for this. My intention here is to, we've got more code to cover. So I think, we'll do this again in a couple Wednesdays. In a couple Wednesdays, and I think I will also take some of this feedback that you have. It'd be interesting. As I was kind of looking at the SQL stuff, it seems like that was kind of a thing. So let's try doing some queries about specific columns maybe in there. We could even try sort of what Deepak was talking about. Let's see if we can fine tune it. But I mean, this is the beauty of this stuff, man. It's just the sky's the limit. I mean, you can play around with this stuff. Just spend a whole afternoon working on this. So. Thank you again, everyone. I will post this on the YouTube channel, on our Applied AI YouTube channel. So if people miss this, please point them off to the YouTube channel. We'll get this up here in the next couple of days, and we'll just go from here. So happy LangChaining, everyone. We'll be in touch soon. Thanks.